Okay, so let's look at the first part, and then we'll get you like kind of started on some of this last stuff and see if you can do it. So this is the rate. This is not the number of t-shirts. It is the rate at which those t-shirts are being printed. So if I want to know how many t-shirts are printed in the first 2 hours, what do I have to do? Area under the curve from 0 to 2. Oops. Sorry about that. There we go. So from 0 to 2, we're looking at this area right here. And so the way you want to write that on a calculator active question is you want to do the integral from, on this particular one, 0 to 2 of e of t dt. Don't skip writing that integral expression because sometimes that's one of the points of the question. And then for this one, you can do it as a rectangle and a triangle. I'm going to do it as a trapezoid. At least write down where you like plug the numbers into the trapezoid. I feel like you should probably do that to be safe. So 1/2 the width of this trapezoid, or the height, would be 2. It really looks more like the width here. And then it'd be 500 plus 700. And that would be 1,200 shirts. Okay. Okay, questions on that part? Okay, B says, is the number of shirts waiting to be packaged increasing or decreasing at t equals 4? Justify your answer. So what do you think on this, increasing or decreasing? Increasing. What is our reasoning? Yeah, so you would say at, and I would use the actual numbers to show that you are not just like guessing at it. So at t equals 4, shirts are produced at a rate of 720 shirts per hour, isn't it? Yeah, hour. But they are only processed at what rate? They are only, or packaged at a rate of 600 shirts per hour. So the number of shirts waiting, add more room, I'd put to be packaged, but I'm going to put waiting is increasing there. So it's really like much more simple than you might think that it is, right? We could probably give this to somebody who does not know calculus, and they could figure that out, right? Without knowing how to find area under the curve or anything. You're just looking at the rate here and the rate that they're produced. There's some other alternatives you could do to like show that. I think this is the easiest way to do that. The hardest part of this question is part C. Has anybody got part C? Anybody got? I think C's where we 6. It's close to 6. It's not exactly 6. It's not 5.
4.
It's not a whole number.
I don't know.
It's not a whole number. There's a few ways you could approach this as well. let's write ourselves an equation for the number of shirts that are waiting to be packaged. So like S, I'm going to call it S for number of shirts. So S of T would equal, how many shirts do you start off with? You start off with 300 shirts, right? And then you need to add the number of shirts that have been printed. What would I do for that? It's not E of T, it's the area under the curve from 0 to wherever you're trying to figure out. So we need an integral right here. So it's going to be the integral from 0 to T, sorry I'm really running out, of E of, I'm going to put an X right here. You can't use the same variable right here as you do right here. So it could be any letter besides T, just not T. Right there. And then, but, okay, so those are the shirts that we started with, the shirts that are being printed. But what else do we have to consider? Shirts are also being packaged, right? So, what should I do for the shirts being packaged? Minus 600 times T, because it's 600 for every hour that has gone by, right? So that equation right there gives the number of shirts waiting to be packaged. Okay. So if I'm looking for the largest number of shirts, like the biggest backlog, that is a maximum. How do I find a maximum using some calculus? I wasn't asking you. What do we set equal to 0 and do a sign line? The derivative of this equation, not this equation, right? This is the number of shirts. We need the derivative of this equation. So I'm going to stop going over it right here for a second and let you guys try to run with that. Because I think we were I don't know the equals 600, which on this graph is right there, which is pretty close to 6, but it's not exactly 6. So if you get the equation of the line, then you could do like y equals 600 over here. That's going to be your fastest way to do that on Desmos. And you're going to get 6.2. So it's going to be 6.2. Another way you could do this, the slope of that line is negative 100. And so you could use point slope form. You could say y equals negative 100 times, you can use either 0.5720 or 10,220. So it'd be, like if I use 5,720, it'd be x minus 720. I'm sorry, x minus 5 plus 720. And that also gives you that equation of that line. That's another option for you there. Like either one of those things will work. You could also do it by hand where you like set that equation equal to 600, but since it is calculator active, it's quicker just to graph it right there. And when you do, of course, we get 6.2. So we would just have to put t equals 6.2 right here. And so that is the place where our derivative of the number of shirts waiting equals 0. So we need to see whether the derivative is positive or negative on either side of this. So we would do 6.2. We want to do 0 right here. You can put a 10 over here if you want because it says that they, maybe I didn't include that. Oh, yeah, because this ends at 10, right? Like our graph doesn't exist past 10. So for S prime of t, if we're plugging in a number between 0 and 6.2, that'd be anything here between 0 and 6.2, so like let's say we pick 1 or 2. Let's go with 2 because it's a whole number. Or it's a point we've got. At 2, my value, my E of t would be 700. 700 minus 600 would give me a positive value right there. And then past 6.2, I could pick any number I want. Let's say maybe like right here at 8 or something. I'm getting somewhere around 400, right? Doesn't matter the exact value. You just know it's a number smaller than 600. So that would give you a negative right there. What does it tell you about S if S prime is positive? S is increasing. And over here would be decreasing. So this question is asking for the absolute maximum. The absolute maximum, where does it have to be? It has to be 6.2 because your graph increases and then it decreases. So that, if it did anything else, if it increased and then decreased and then went back up, then we'd have to check some more stuff. But we would say since S prime of t, this is going to take up some room, is greater than 0 for 0 less than or equal to t less than or equal to 6.2. I guess I should say just less than's there, not or equal to, equal 0 at some of those points. Since we have a positive derivative here, S increases on that interval. Since S prime of t is less than 0 for 6.2 less than t less than 10, S decreases on that interval. So, S has an absolute maximum at t equals 6.2. You do have to tell, because like just getting that number doesn't guarantee, it could be a minimum point possibly, like if the graphs look different. So you do have to put this explanation right here. Now the question does ask us how many t-shirts it is, right? So we're still not done with this part. This part's really long. How am I going to find how many t-shirts it is? What did this equation right here give us? Number of t-shirts waiting, right? So we're going to plug into that. So we're going to do S of 6.2, which is going to be 300 plus the integral from 0 to 6.2 of e of x dx minus 600 times 6.2. And especially since I'm sure you're about getting close to being out of room on your warm-up part, don't worry, D's like one line. Here, we can do this. Oh my gracious. Everybody go check your phone, and you can keep it with you today. Oh gosh, I hope everybody's phone's all right. I had it stapled. I mean, there's push pins at the top, but I had it stapled all around too.
Mine's already cracked.
Is everybody's phone okay? Everybody check your phone. And you can just put it in your book bag or something today. It didn't really, did it? Okay.
Well, you want to see the back of mine? It's always been like this.
Yeah. Maybe double check with me tomorrow that I've reinforced that. I'll put 1,000 staples in it tomorrow.
It's like under.
Poor Joshua thought he was getting shot.
Yeah. Isabella, all the cell phones just fell out of the cell phone holder if you're watching this. Let's pause. The next little piece right here is going to be just this little sliver right here. And so if we had more room, it wouldn't hurt to write it down. But it's going to be 1/2 times 1 times 700 plus 720. That'll be that green part. This part right here is just a rectangle. So what do we do for it? Base times height. So that's going to be 2 times 720. So we got plus 2 times 720. And then we want to do this last part, but we're stopping at 6.2. So it's like this little piece right here. So that's a trapezoid. What's the width? Not 1. It's going to be 1.2. And then we got 720 for that one side. What we need for the other side is the y coordinate right there, which is 600. I should have known that because that's where we were stopping. Plus 600. So for that area under the curve, we're getting 4,142. Okay, so if I go back down here, zoom back out a little bit. If I go back down to this bottom part, that was just this piece. So that is going to be 300 plus 4,142 minus, what do we get there? 1220, 600 times 6.2. Oh, 600. Oh, I was maybe close. 2.6, I think. 3,720. So if we do all that, 300 plus 4,142 minus 3,720, we will get 722 shirts. It's actually a different number than I got here. But, I mean, I just made this problem up, so I made the key. Y'all don't see a mistake I made, do you?
You did it right.
I think this is right.
What if you
I
have
think
one
so.
like this and then you ran out of room in your little box?
They will grade, if you run out of room, they will grade things if it goes into, like, if your answer is not where it's supposed to be and you've accidentally put B in C. This would usually only happen if a kid left a part blank. Like they were going to leave B blank, but then they accidentally answered C in their B part. But if it's not where it's supposed to be, you're still supposed to grade it if it looks like the work to your problem. So if I would, first of all, try to keep it in the box. They generally give you a pretty good amount of space. So I think you should be able to keep it in the box. If you absolutely cannot fit it where it's supposed to be, maybe just put it in, draw an arrow down here and put it in the next box. If you
draw a little box extend
yeah, I think that would be okay. Yeah, don't go outside of the margins because they scan these in. So it might get cut off if you go outside of the margin. So you're better off extending part B down into part C or something, and sort of boxing that off. But they should still grade it if you do that. Because whenever kids left a problem blank, I had to go flip through the rest of the test to just see if they had maybe accidentally answered question 2 on question 3's spot. So they should still grade it as long as you have the right work, and especially if you put arrows or boxes and like make it clear that this is still that same part, that they should be good. Okay? All right, last part. Last part here says, write but do not solve. That's always kind of like a nice thing to see, do not solve, because it's going to be, it usually means it's going to be quick. Write or do not solve an equation involving an integral expression of E whose solution gives the earliest time at which there are no longer any t-shirts to be packaged. So, if you could maybe answer part C without setting up this S of T equation. But if you set it up, it makes part D really easy. Right? Because what did we say this is right here? Number of t-shirts waiting to be packaged. Right? So what should we do if we want to find an equation where there's no more t-shirts waiting to be packaged? Set that equal to 0. So if you've already set this up here, then all you really have to do, you probably, for part D, could get away with saying S of T equals 0. Because they specifically say involving an integral function, I would take the equation 300 plus integral from 0 to t of e of x dx minus 600 t equals 0. I would write that. You don't have to solve it. You're just writing it.
That's what we already had.
Yeah, it's what we already had. You don't necessarily have to write